All right, so we just got done talking about how to identify the slope of a line. And so now we're going to continue reviewing linear functions, and we are going to learn how to write the equation of a line. We're going to look at this a couple different ways. We're going to look at how to write the equation of a line if we already know the slope, and we're going to look at how to write the equation of a line when we don't know the slope. Okay? Let's start with a situation where we're going to start with when we don't know the slope. Let's start with what we had before. Let's say instead of being asked what's the slope of the line between 2 points, what if you were asked, write the equation of the line that passes between 2 points? Now I want to say, usually what you'll be asked is to identify the equation of the line that passes through 2 points. And one of the reasons for that is because usually we assume that a line goes off to infinity in both directions. But what you're eventually going to learn, what you're eventually going to get to, is you're going to start learning about lines that don't go off to infinity in both directions. They stop at the points, and they still have an equation, and when you graph them, they would only go from this point down to that point. That's why I'm saying the equation of the line that passes between 2 points or connects 2 points. Okay, so, but either way, the equation of the line is the same, whether it goes off to infinity in both directions or whether it stops at the 2 points. The equation is still the same. So let's say we want to write the equation of a line that passes through the points 2, 10, and 7, 19. Okay, we got 2 points on the coordinate plane. We've got 2, 10, and then we've got 7, 19, and we want the equation of the line. Okay. All right, well, I am first, before I teach you slope-intercept form, I'm going to teach you point-slope form, because in my opinion, it's easier to write the equation of a line in point-slope form. In order to write an equation in point-slope form, you only need 2 things. You need a point. Well, there's 2 of them here. I only need 1 of them. You need a point and you need a slope. Well, I'm about to find the slope. I just learned in the last video, we just talked about how to identify the slope of a line. If I know the slope and I know the point, all I have to do is just plug them into a formula. Okay? So let me show you the formula real quick. Point-slope form of a line is going to go like this. It's going to have the letter y in it, and that's the answer itself is going to have the letter y in it, okay, because it's a function, okay, minus some number. So it's going to be y minus some number is equal to some number, then a parenthesis, times x minus some number. This is what the formula looks like. So, for example, let's say we have y minus 17 is equal to negative 3 times x minus 6. This is the equation of a line. This is point-slope form. We have y minus a number equals negative 3 times x minus a number. Okay, well, it's this negative 3 is a number. So we're supposed to have a number here and a number here and a number here. But then here and here we just have the letters x and y. Okay, so now here's the thing. This could be a plus. This could say y plus 17. Now, it'll only say plus if the number that you put here is a negative value. For example, if we put a negative 5 here, y minus negative 5, well, that would be y plus 5. So it can be y minus a number or y plus a number. All right? But our basic formula is this y minus a number equals a number times x minus a number. But the way we write the formula is we write it as y minus y1, where y1 is a number, it's a y coordinate, equals m, the slope, times x minus x1. And here's where the point-slope form comes in. Here's the point, xy coordinate, right? All points are made up of an x and a y. Okay? And then here's the slope. Point-slope form. And this works every single time. And this is actually easier, and I'm going to show you why in just a minute, why it's easier than putting a function in slope-intercept form. Now, slope-intercept form is actually easier when you're dealing with graphs. But point-slope form can be just as easy when dealing with graphs. So if we're going to write the equation of the line that connects these 2 points, if we're going to write it in point-slope form, we need a point. Well, we have 2 of them, and now we need a slope. So the slope equation is m equals y2 minus y1 over x2 minus x1. Okay? So we just saw this in the last video. So now we're going to put in an xy coordinate here. So let's see, here our y value is 10 minus, our x value is 2, we'll put that on the bottom, minus. Then over here we need another y and an x. Our y value here is 19, and our x value here is 7. And so we have 10 minus 19, that's negative 9, over 2 minus 7, that's negative 5. And a negative divided by a negative, that's a positive. So this will be 9 over 5. So the slope of the line between this point and this point is 9 over 5, or 9/5. Okay? So now that we have our slope, and we have we have to pick one of these points. It doesn't matter which one we pick, so let's pick this one here. We'll pick the point 210. So when we write the equation of a line in point-slope form, we're going to write y minus and then a y value. Well, our y value from the point is 10. So y minus 10 equals slope m, right? In this case, the slope is 9/5. So put 9/5, then a parenthesis, x minus, and then the x value from the point, which is 2. And so x minus 2. And this is the equation of the line in point-slope form. All right? Let's do another one of those. Let's see here. We'll just pick a point, or pick 2 points, and then write the equation of a line. So let's say we want the equation of the line that passes between the points negative 5, 7, and 4, 1. All right. So why don't you maybe pause the video and see if you can figure this one out on your own. All right, so here's what we're going to do. Remember, our formula is y minus y1 equals m sloped times x minus x1, right? So this is our formula. This is our point slope form formula. We need a slope. Well, to find the slope, we're going to do y minus y, 7 minus 1, over x minus x, negative 5 minus 4. Well, 7 minus 1, that's 6. Negative 5 minus 4, that's negative 9. A positive divided by a negative is a negative. So the slope is going to be a negative slope. 6 over 9, well, that reduces to 2 over 3. So our slope is negative 2/3. So now, let's pick this point right here, the 4 and the 1. So our equation is going to be y minus 1 equals slope negative 2/3 times x minus 4. And there we go. That's the equation of the line in point slope form. Okay? All right, now what I'd like to do is I'd like to take this line right here, this y minus 1 equals negative 2/3 times x minus 4, and I would like to write that in slope-intercept form. So let's say that so slope-intercept form, you probably know that one, is y equals mx plus b, where the y is just a y, we're not going to put a number in there. The x is just an x, we're not going to put a number in there. And then we have m, that's the slope, and we have b, that is the y-intercept. That's where the line crosses over the x-axis. That's where the line crosses over the crosses over the y-axis on the graph. Okay, so.
Teachers, all students should be in class at this time. If you have any students that have not made it to class, please send them to the front kiosk for a pass. Thank you.
So this B, that's the y-intercept. That's where the graph crosses over the y-axis on the graph. Okay, so here's what we're going to do. Basically, we're going to take this y minus 1 equals negative 2/3 times x minus 4, and we're simply going to rearrange it so that the y is all by itself. That's all we're doing, is we're just solving for this so that the y is all by itself. Now, one really easy thing you can do here is you could just add 1 to both sides. And now you have y equals negative 2/3 times x minus 4 plus 1. All right? And this is almost in slope-intercept form. Here, we're going to have to distribute the negative 2/3. We're going to have to do negative 2/3 times x, and then negative 2/3 times negative 4. So negative 2/3 times x, well, that's just negative 2/3 x. Negative 2/3 times negative 4, well, let's go over here on the side and multiply that. Negative 2/3 times negative 4. Well, negative 4 is actually negative 4 over 1, right? So negative 2 times negative 4 is positive 8, and 3 times 1 is 3. So this is 8 over 3, or 8/3. That's positive 8/3. So here we're going to put plus 8 over 3 plus 1. But instead of putting plus 1, let's put plus 3 over 3, because we want to add these two fractions. We want to combine like terms. Or not combine like terms, sorry. We need a common denominator. Sorry, that's what I meant to say. We need a common denominator. And 8 plus 3, well, that's 11. So here's what we're going to have. Y equals, this is going to stay the same, negative 2/3 x plus 8 plus 3 is 11. 11 over the common denominator 3. And now we have this same line right here is now in slope-intercept form. Okay? Let's do another example. I'm going to give you 2 points. We're going to turn it into point-slope form. Then we're going to transform it into slope-intercept form. I'm going to try and give you one that doesn't have any fractions, okay? Just give me a minute. All right, so we got these 2 points. We got negative 2, negative 10, and then 3 and negative 25. And so we want to identify the equation of the line that connects these 2 points, right? Okay, so we'll do the slope first. So the slope is going to be one of the y values, negative 10, minus the other y value, negative 25, over the x value that goes with negative 10, which is negative 2, minus the x value that goes with negative 25, which is 3. Negative 10 minus negative 25. Well, this minus negative, that means plus, right? So negative 10 plus 25, that's 15. Over negative 2 minus 3. Well, negative 2 minus 3, that's negative 5. And so 15 divided by negative 5, that's negative 3. So the slope of this line is negative 3. So over here, we'll say m is equal to negative 3. All right, well, we got that. Now we're going to write this line in point-slope form, right? So point-slope form takes, and you may want to write, if you haven't written this down already, you need to write it down. The form of point-slope form, y minus y1 equals m times x minus x1, okay? So point-slope form, y minus, we only need to pick one of these points. Why don't we use this one right here? Let's use negative 2 and negative 10. So it's going to be y minus negative 10. Okay, so y minus negative 10 equals slope, negative 3, times x, that's a negative by the way, x minus the x value that goes with the negative 10, which is negative 2. So we'll put that in parentheses, negative 2. And now look, the reason I put it in parentheses is because we have a negative negative. Well, what does negative negative mean? It means plus, right? So we'll go y plus 10 equals negative 3 times x negative negative again, x plus 2. And this is, there we go, there's our point-slope form. We're done. That's the point-slope form of a line. Now, in order to turn it into slope-intercept form, we need to distribute the negative 3 here and here. Okay, so we're going to have negative 3x, negative 3 times 2 is minus 6. Then we got our y plus 10. Now all we have to do is subtract 10 from both sides so that we can get the y all by itself. And we get y equals negative 3x, negative 6 minus 10, that's minus 16. And there's our slope-intercept form. So you're going to want to do a bunch of these as well so that you understand. Here's the thing is, this is not just one thing. What we're about to do in class is we're about to take this and move forward and learn other things with this. So if you are not able to do this, you won't be able to do any of the other things that we're going to do in class. So you have to, this is something you got to spend, If you have to spend hours on this, it is worthwhile because it's going to affect your math career probably for years to come. Pretty much every math class at some point or another continues to go back to the linear equation. All right? What if instead of being given 2 points, what if you were given a slope? What if you were just told that the slope was 5 and that it passes through a point 7, 9? Well, this is even easier because now you don't have to find the slope of the line. Okay? So we're going to first put it into point slope form, which is y minus y1 equals slope times x minus x1. All right? So y minus the y value, 9, equals slope, which is 5, times x minus the x value, 7. And there we go. There's point slope form. And now let's turn it into slope-intercept form. First, we're going to distribute the slope to the x and the negative 7. So we'll have y minus 9 equals 5x. 5 times negative 7 is negative 35. Then we're going to add 9 to both sides. We're just solving for y. And we get y equals 5x. Negative 35 plus 9 is negative 26. And so this is the equation of the line in slope-intercept form. All right? So this is something that you should practice a lot, like I said. What we're going to do in the next video, I think we're done with this. We're going to move on to understanding parallel and perpendicular lines.